Let's start this session. Am I audible to all of you? Just confirm once. Hello, am I audible?
Yes, sir.
Okay. Okay, कितने लोगों ने वो प्रॉब्लम सॉल्व की? The one that I gave you last in the last lecture. वेदांत ट्राई किया आपने?
No, sir.
Okay, okay, no problem. Okay, so let me start. Let me share this. I hope that it is visible to all of you. So these were the problem. Can you tell me whether this first one is time invariant or not? So whether this one is time invariant or not, first one, or time variant or time invariant. Can anybody guess? First one, second one, and third one, whether they are time invariant or not. So this is time invariant. This is also time invariant, and this should be time variant. Okay. So let's see them one by one, and then we will move on to other properties. Let's see the first one, and for that I think I need to copy this image first. Okay. Okay. Uh, let me remove some of these. Okay, so this is xt. These things are going to be different here, and this is going to be different. So the very first is that yt here. Let me make this in different color. Okay, so here y of t, the system that is given is yt is equal to cos of xt. So what the system is doing is that it's taking your input and applying cos function to that. Okay, that should be clear to all of us. So when we are applying delay to the system by t naught, so we will get x of t minus t naught. And then after that, when we apply cos, what we will be getting? Cos of x t minus t naught. Because what our system is doing, it is basically applying uh, cos to whatever the input that we are providing it. When you apply system, what you will be getting here as cos of xt. And when you put t equal to t minus t naught, you will be getting cos y of t minus t naught is equal to cos of x t minus t naught. So we can see that both of these are equal. So this is going to be time invariant system. So this is time invariant system. Okay. Uh, let's see the second one. And I will have to do the same thing again. Okay. So now our system is okay. So let me so as you can see with this third one, the second one x square t, it's kind of similar only as that of the first one. So y of t here is equal to x square t, and here again what you will be getting is what this is going to be x square t minus t naught, right? And when you apply this you will be getting x square t, and when you put t in, replace t with t minus t naught, you will be getting x square t minus t naught. So both of them are again equal, and this system will again going to be time invariant. Okay. So one thing you can note here, that whenever you are applying any operation on magnitude of xt, magnitude of the input, it's not going to change the time variance or invariance of the system. If the system is time invariant, it will remain time invariant. Whenever there is operation on t, and that too not shifting. Shifting, we have already seen that shifting is time invariant only. But when you are applying scaling there in the time, then it will become time variant. And one of the example here is this third one. Okay. So let me again just. Okay. So let's see this third one. And the system that is given here to us is yt is equal to cos of xt plus x of 0. Okay, and we will see that x of 0 is basically x of 0 time t. Okay, and that's why we are doing scaling here. So this is going to be what you can say time variant system. Okay, and we will see that what is going to happen here. xt, you have applied delay here, you will be getting x of t minus t naught, and here you are applying system. So what you will be getting cos of xt plus x of 0. Okay, so this is what you will be getting here. Now you are applying system here, right? Time system आप यहाँ पे apply कर रहे हैं, and what you will be getting, आपका system क्या कर रहा है? It is taking cos of your input, that is x of t minus t naught, and then it is putting t equal to 0 here. So you will be getting x of minus t naught here. Is this clear? Now in this part, when you are applying replacing t with t minus t naught, what you will be getting cos of x of t minus t naught, and this is going to be x of 0 only, isn't it? It's going to be x of 0. t को replace कर रहे t minus t naught से. So can you see that these two are not equal now? So this system is going to be time variant. Okay, so it's very easy to see. If you see solve some problem, it will be very easy for you to see all these things. Okay, is this clear? So time invariance variance is clear to all of you? Hello, clear हो गया आप लोगों का ये time invariance variance?
Yes,
Okay, okay, let's move on to the next property, and that is going to be, we have already seen linearity, time invariant. Now we will be seeing instantaneous and dynamic system, and which is very easy to see actually. So we'll be saying instantaneous yes versus dynamic system. Okay, and instantaneous system is one that depends upon present input only. Okay, otherwise the system is dynamic. So a system whose output a system uh, in which output at time t depends on the value of input at time t only is instantaneous system. Otherwise system is dynamic. So otherwise system is dynamic. Okay. So uh, the highlight here is that output should depend upon the present input only. Okay, and then system is going to be instantaneous. So let's see some of the example. It's quite easy to see actually. So we have a output yt which is like this, sine of xt. Whether this is going to be instantaneous or dynamic,
Instantaneous.
it's going to be instantaneous. Okay, let's see another example. These are all examples here. Another example is that output yt is x of 2t. Whether this is instantaneous or dynamic, output at 1 will depend upon x of 2, right? So it's
So
going to be
dynamic.
dynamic, right? So it's going to be
Oh,
dynamic. So it's quite easy to see actually. Okay. Another example here can be yt is equal to e to the power x of t plus 2. Whether this system is instantaneous or dynamic.
Dynamics.
Dynamic. Okay, so this is dynamic. So in the similar line of instantaneous and dynamic system, I'm not going to take many examples here. It should be a self-explanatory kind of thing. Okay, let's see next thing, that is causal and non-causal. So we have three categories there. Let me just discuss all of them. So we have causal system, and then we have non-causal system, and then we have what is known as anti-causal system. Okay, and I mean this is very easy to see actually. So let's me just discuss the definition of the causal. Okay, so causal means which is going to follow cause and effect. So all the physical system that you see in your life are causal system. Cycle आप देख रहे हो, car देख रहे हो, any system that can be implemented in real time, all of them are causal system by default. Okay, and why they are causal? Let's just investigate that. So let's see the definition of this causal system. So a system that depends upon present and past input only. Okay, so causal system is one that depends upon present, okay, and past input. Is this clear? So a system that depends upon present and past input only, that is going to be called causal. And as you can see that all the physical system that you will see will depend upon either present input or past input. They can't see future. Real time में आपको future input क्या होगा वो कभी नहीं मालूम रहेगा, right? So you can't really, your output can't depend upon something that is not going to happen in real time. So that's why these systems are also called physical system. So another name for this causal system is physical system. Okay, and only is cause only is causal. So causal I have already seen. Let's see the non-causal now. So non-causal, a system which is not causal will be called non-causal. And की जगह and और लिखता हूँ मैं यहाँ पे. Okay, so that should be clear. It's and as well as or. Okay, so non-causal system, a system that depends upon the future input. Okay, that will be non-causal. So any system which is not causal is going to be non-causal. So it depends upon future input. So by definition, it depends upon future input. And this system cannot be implemented in real time unless you have data. So most of the time when you are doing offline analysis, then you generally have the complete data, uh, present as well as past. Especially another kind of non-causal system is when you are implementing system in space. Okay, so in space, future input is kind of available there. Okay, because there is no concept of time there. ओके फ्यूचर आपका जो होता है टेम्पोरल सिग्नल में ही प्रेजेंट और पास्ट इनपुट का है. व्हेन यू हैव फिजिकल सिस्टम विच आर लाइक they are function of space, then you will see that those data are kind of available. Future data is kind of available there. Okay, or if you have some data that is already stored, then that system can be non-causal. But physical system can't be uh, anti-causal or non-causal. Okay, and then we have anti future input as well as input and or past input. Let me write this and or past input. Okay, I mean it's quite easy to see. Anything that is not causal is non-causal. Okay, and then the third one that we have is anti-causal. So a system which depends upon future value only, upon future value only, is anti-causal. Okay, so it depends upon future value only. Then the system is going to be anti-causal. So we generally classify between causal and non-causal, but sometimes they can ask you question based on anti-causal as well. Okay, so let's see some example here. It's kind of like that, instantaneous and dynamic. So let's see some example here. So let's say that you have yt and yt is equal to cos of xt. Tell me whether this system is causal or anti-causal or non-causal.
Causal.
It's causal.
Okay, just wait for some time. Sir is facing some issues, right? So once he's restarting his laptop, correct? Okay, sir. Hmm.
Uh, am I audible? Hello, am I audible?
Yes, sir.
Okay, I kind of. Okay, just a minute. Let me share this. Okay, is this screen visible to all of you? So let's see some example here. Let's say that we have a system in which given that yt is equal to let's say cos of x of 2t. Okay, tell me whether this system is causal or not. Causal or non-causal or anti-causal.
Causal.
Is it causal? Y of 0 will depend upon what? Cos of. I put t is equal to 0. What cos of x of 0, right? So from here it looks like that it depends upon the present input. Let's say y of 1. Okay, so we always see x y of 0, y of 1 and y of 2. Okay, to see this. So This is going to depend on x of 2, isn't it? So 1 के लिए 2 फ्यूचर में है या पास्ट में है? Is it in future or is it in past?
So
future,
Future, right? And causal system by definition should depend upon present or past value and not on the future value, right? So this is going to be non-causal. क्या होगा सिस्टम आपका? Non-causal होगा because it depends upon future value. Let's see another example in the similar line. Let's say you have cos of x of mod of t. Tell me whether this system is causal or anti-causal or non-causal. So y of 1 will depend upon x of 1, right? And y of minus 1 will depend upon which value? X of minus 1 का mod means 1 only, isn't it? Tell me now, at minus 1 के लिए 1 future में है, past में है, कब है?
future,
फ्यूचर में.
So this is going to be non-causal again. Okay. Let's see another example. Let's say you have see some example of causal system. Let's say you have x of t minus 3. Tell me whether this is going to be causal or not.
yes
So
sir, causal,
no matter what is the value of t you will take, t minus 3 is always going to be less than t, isn't it? So this is going to be causal always. And let's see one example of anti-causal, yt equal to x of t plus 3. No matter what is the value of t, t plus 3 will always be in future, isn't it? So something that depends only on future is going to be anti-causal. And you can call this non-causal as well. Okay, so anti-causal भी बोल सकते हैं, non-causal भी बोल सकते हैं. Is that clear to everyone? How to recognize whether a system is causal or not?
Yes, sir.
Okay. So we have seen these instantaneous, dynamic, causal, anti-causal, and non-causal. And now we are going to see a stable system. Okay. So we will see stability, whether the system is stable or not, or whether the system is unstable or not. Stability. So there are many definitions of stability, but when you have input and output relationship, like the one that we have been exploring till now, yt is given in terms of xt, then the most common definition that we take is called as BIBO stability. So we are checking for BIBO stability, and we will in future explore stability in detail. So BIBO stability. What does this mean? क्या होता है BIBO stability का meaning?
बाउंडेड
Bounded
इनपुट.
bounded input, bounded output stability. Okay. And what is the meaning of bounded? Can somebody tell me what is the meaning of bounded? Uh, Somebody please tell me, do you understand what is the meaning of bounded? Hello? Well, see, this is not a compulsory class, right? So if something is not compulsory, it's free for you, right? फ्री का मतलब ये नहीं है कि आप आएंगे खाना खाएंगे जाएंगे, इसका मतलब है आपको आना है यहाँ पे पार्टिसिपेट करना है. आप पार्टिसिपेट नहीं करेंगे तो कैसे लेक्चर चलेगा? If you don't know something, tell me that you don't know, okay? But please respond.
Sir,
Hello?
a specific interval.
A specific interval. Okay, you are kind of in the line. So we say that a signal is bounded. Let me just define this. Signal is bounded when a signal, to be specific, let me write this signal xt is bounded when uh, mod of xt is less than equal to some constant m of x, and this m of x can be any constant. Okay, and this, it is finite constant, means it is less than infinity. So we say that a signal is bounded when mod of xt is less than mx, and that is less than infinity. And pictorially, what does this mean? That let's say that you have a signal, okay, which is something like this. Now you can draw two lines parallel to x-axis, okay, जिसके बीच में होना चाहिए ये सिग्नल. जैसे साइन वेव है, साइन वेव क्या है? बाउंडेड है. साइन वेव की मैक्सिमम वैल्यू क्या होती है? 1. मिनिमम वैल्यू क्या होती है? -1. आर यू गेटिंग माई पॉइंट? So that signal will be called bounded by the value 1. It's always less than equal to 1. Its mod value is always less than equal to 1. Is that clear? Hello?
Yes,
Yes,
sir.
sir.
Okay.
Yes,
So
sir.
let me just see one few more example of this. Uh, just tell me whether UT you are already familiar with, right? So whether UT is bounded or not.
Sir, its upper bound is at infinity.
No, where is infinity? Time की बात नहीं कर रहा हूं मैं. I'm talking about its magnitude only. What
Sir,
I
there
have
are
written.
bounded.
Let me write here for all time t. Okay, for all t. टाइम से मतलब नहीं है, यहाँ पे वैल्यू से मतलब है. वेदर दिस कैन बी, आप दो लाइन खींच सकते हैं यहाँ पे जिसके अंदर होगा ये. आर यू गेटिंग माई पॉइंट? ut इज इक्वल टू क्या है? ut की वैल्यू 1 and 0 only, isn't it? So its value is always finite, isn't it? Can you see that?
Yes, sir.
So if the किसी भी सिग्नल का वैल्यू हमेशा फाइनाइट है, इसका मतलब क्या है? वो बाउंडेड है. आर यू गेटिंग माई पॉइंट? So DC signal, let's another example of bounded signal is DC signal. Okay, आपका DC signal जो है constant K है, let's say. So whether this is bounded or not.
Bounded.
So it is also bounded, right? And can you give me one example of unbounded signal जो infinity हो जाए?
Sir, impulse function.
Impulse function is unbounded. So the impulse, its value becomes infinity, isn't it? इसका वैल्यू क्या होता है? इनफाइनाइट पे चला जाता है, राइट? सो यू कांट ड्रॉ ए लाइन हियर. दो लाइन नहीं ड्रॉ कर सकते हैं जिसके बीच में हो ये. सो दिस इज अनबाउंडेड. अनदर एग्जांपल ऑफ अनबाउंडेड सिग्नल इज e टू द पावर t. e टू द पावर t को आप अगर ड्रॉ करें तो वो क्या होता है? ऐसे जाते रहता है. सॉरी, आई हैव ड्रॉन इट काइंड ऑफ लाइक ए लाइन. लेट मी ड्रॉ इट प्रॉपरली. So we have this signal e of t, which is like this, and you can see that this signal is growing unboundedly, right? So this is going to reach infinity, so this is again going to be unbounded. Is that clear? ये क्या e
Yes.
to the power t? E to the power t is unbounded signal. So bounded unbounded का meaning समझ में आ गया?
Yes, sir.
Okay. Now let's move on to the definition of BIBO stability. So BIBO stability. So if it says that if xt is bounded, then uh, then yt must be bounded for a BIBO stable system. इसका मतलब क्या है कि अगर xt इनपुट बाउंडेड है तो आउटपुट बाउंडेड ही होना चाहिए फॉर द सिस्टम टू बी BIBO स्टेबल. इज दिस क्लियर? समझ में आ रहा है आप लोग को?
Yes, sir.
Yes, so in other word, if mod of xt is less than equal to mx, which is less than infinity for all time t, then to be BIBO stable, mod of yt should also be less than some constant my, and it doesn't really necessarily means that my has to be less than equal to mx or my has to be greater than equal to mx. It's just a constant which is less than infinity for all time t. Okay, and how we are going to test whether a system is stable or not? To test BIBO stability, we will use UT. ठीक है, UT is a bounded signal, isn't it? So UT अगर इनपुट देंगे तो आपका आउटपुट जरूर क्या होना चाहिए? वो भी बाउंडेड होना चाहिए, राइट? है ना? So our test signal is going to be UT. And to understand BIBO stability, you can like use this analogy of a sane person, right? So a person is going to be called sane if someone is behaving sanely in front of me and I am behaving insanely, then and then only I will be called insane, right? लेकिन अगर सामने वाला insanely behave कर रहा है तो I can behave insanely, then I cannot be called insane, isn't it? बात समझ में आ रही है क्या आपको? जब सामने वाला sanely behave करेगा तो मुझे sanely behave ही करना है, then and then only I can be called sanely. Okay, so let me just take some example here. So let's see this example of yt is equal to xt. Whether this is stable or not, BIBO is stable or not. If xt is equal to ut, what will be y of t? Yt is also going to be ut only, isn't it? होगा?
Yes,
Yes,
sir.
sir.
So it means this system is BIBO stable. आपको तब तक समझ में नहीं आया जब तक हम अनस्टेबल सिस्टम ना ले. So let me take another second example where yt is equal to let me write this d of xt divided by dt. Tell me whether this will be BIBO stable or not. Let xt be xt equal to ut. Then what is going to be the value of yt here? That will be d upon dt u of t. What this is? Differentiation of ut क्या होता है? डिफरेंशिएशन ऑफ यूटी जो है वो डेल्टा टी होता है। शायद मैंने ये कराया नहीं, लेकिन मैं करा दूंगा आप लोग को कभी। ठीक है, सो ये क्या होता है डेल्टा टी। तो यू टी एक्स टी क्या है, यू टी विच इज बाउंडेड, एंड वाई टी क्या हो गया यहाँ पे डेल्टा टी। डेल्टा टी बाउंडेड है, नो इट इज अनबाउंडेड, राइट। So it means this system is going to be what? BIBO unstable. Is that clear? Let's see another example to complete this. Let's say yt is given as minus infinity to t xt dt. And let's see if xt is equal to u of t, then what will be yt? Yt will be minus infinity to t ut, isn't it? And ut dt actually. So what this is going to be, this will be equal to RT. And RT is a unbounded signal, isn't it? RT कैसा होता है आपका, ऐसे increase करते जाता है all the way it's going to become infinity, isn't it? So this system is again going to be what? BIBO unstable. Is this clear to everyone?
Yes, sir.
Yes, sir.
Okay. And let's just see one more thing that anyway you are going to understand that later in detail. But let me discuss that. I will complete signal discussion after this. Okay. So we have seen this, and another type of LTI system is linear time invariant system. Okay. So linear time invariant system को हम लोग constant coefficient differential equation से भी represent करते हैं. So you can have something like this: d2 yt by dt2 plus 2 dyt by dt plus let's say yt, and that is equal to let's say dxt by dt. Okay, you can have a linear differential equation here, and then they will ask you the system that is being represented by this linear differential equation is stable or not. Okay, तो उसको हम लोग कैसे देखते हैं? पहली बात, this kind of system will be unstable if differentiation of xt is more than differentiation of yt. Is that clear? यहाँ पे क्या है 2, और यहाँ पे अगर मैंने 3 कर दिया तो ये क्या हो जाएगा? अनस्टेबल सिस्टम. आर यू गेटिंग माय पॉइंट? Is that clear?
Yes, sir.
And after that, once you see that, once you verify that dxt by dt is less than this, okay, x का differentiation y से कम है, then after that you have to see this characteristic equation here. Okay, so characteristic equation for a proper system. Proper system का मतलब xt का differentiation yt से कम ही होना चाहिए. Okay, then we will see characteristic equation, and actually we will see roots of characteristics equation. Roots of characteristics equation. What is characteristics equation? आप dy t by dt को यहाँ पे d स्क्वायर लिख दो, इसको लिख दो 2d, और इसको लिख दो, अब ये 1 हो जाएगा यहाँ पे. इज दैट क्लियर? जितना ऑपरेटर है वो लिखना है. ऑपरेटर डी स्क्वायर है तो डी स्क्वायर लिखा, यहाँ पे 2 टाइम्स डी है और यहाँ पे डायरेक्ट 1 है, and that is equal to 0 is going to be your characteristic equation. And all these roots of this equation must be negative, okay, for system to be BIBO stable. Is that clear? अब इसका बताओ, ये character, इसका roots क्या होगा? This is d plus 1 whole square, isn't it?
-1.
So d equal to 2 roots आए, दोनों -1 -1, दोनों नेगेटिव हैं. इसका मतलब सिस्टम क्या होगा आपका? स्टेबल। इज दिस क्लियर? रूट्स ऑफ कैरेक्टरिस्टिक इक्वेशन must be negative for a system to be BIBO stable. Is this clear? And we अब ये आपको ऐसे याद रखने की जरूरत नहीं है, हम लोग आगे जब जाके पढ़ेंगे ना, when you see Laplace transform and transfer function, then you will easily be able to do this without even looking for characteristic equation. Okay? Laplace transform में आपको मालूम है सारे रूट्स क्या होने चाहिए? लेफ्ट हाफ प्लेन में होने चाहिए. So we will see that again there in that case. But there are certain questions which you can solve just by applying UT. Okay? और वो आपको मालूम होना चाहिए. So you will explore this and it will be clear to all of you. Okay. Now, since we were discussing this, let me discuss. We have already discussed this spatial signals like UT, delta T. हमने discuss कर दिया RT. किया? Okay. So let's say I have delta T, and so this is the topic where relationship between UT, delta T and ये पढ़ने वाले हम लोग. So relationship between delta T, UT and RT. ओके तो रिलेशनशिप मैं बता दे रहा हूं आपको. डेल्टा टी को आप इंटीग्रेट करेंगे माइनस इंफिनिटी टू टी, देन यू विल गेट यूटी. और यूटी को आप इंटीग्रेट करेंगे माइनस इंफिनिटी टू टी, देन यू विल गेट आर ऑफ टी. ओके, और आर टी को आप डिफरेंशिएट करेंगे डी अपॉन डी टी, तो क्या मिलेगा आपको? यूटी. यूटी को डिफरेंशिएट क्या करेंगे तो आपको क्या मिलेगा? डेल्टा टी. So this is the relationship, but I'm going to prove this here. Okay. लेकिन हम लोग इसको प्रूव भी करेंगे. Okay. So let's just see that. अभी अब बताइए डेल्टा टी का मुझे करना है लेट्स से माइनस इंफिनिटी टू टी डेल्टा टी. Okay, what this is going to be equal to? Can somebody tell me? If t is less than 0, then what this value is going to be? डेल्टा टी कहाँ पे होता है? t equal to 0 पे?
at 0.
And
At
when you
0.
have t less than 0, then this value is going to be what? 0 only. And if t is greater than 0, equal to 0, then what this is going to be? आप डेल्टा t इक्वल टू 0 है और 0 से आगे तक इंटीग्रेट कर रहे हैं आप, तो ये वैल्यू कितना हो जाएगा? एरिया ऑफ डेल्टा t, एंड एरिया ऑफ डेल्टा t इज इक्वल टू व्हाट? 1,
1.
राइट. एंड व्हाट इज दिस फंक्शन जो t इक्वल लेस देन 0 से 0 हो और t ग्रेटर देन इक्वल टू 0 से 1 हो? ये फंक्शन को हम लोग क्या बोलते हैं? यूटी बोलते हैं, राइट?
Impulse.
Unit step signal. So unit step signal is minus infinity to t delta t dt. Okay. Similarly, if you integrate minus infinity to t u of t, so we know that ut is equal to what? Equal to 1 for t greater than equal to 0, and it is equal to 0 for t less than 0, right? ut आपका किस तरह से फंक्शन है? इस तरह से है, सॉरी, isn't it? So what this is going to be equal to? Can you tell me? When t will be less than 0, यहाँ t रहेगा आपका, तो आपका इसका वैल्यू क्या आएगा? When t is less than 0, it will be equal to 0 only, isn't it? When t is greater than equal to 0, what this is going to be? This will be minus infinity to 0, 0 dt plus 0 to t 1 dt, isn't it? So ये तो 0 मिल गया और ये क्या मिला आपको? t, right? So this will be equal to t. और इस फंक्शन को हम लोग क्या बोलते हैं? rt. right? So you can write this that minus infinity to t, u of t is going to dt is going to be equal to rt. And similarly, since differentiation is just opposite of this integration, okay? In engineering, we take this minus infinity to t as integration. Instead of writing indefinite integration, we write semi-indefinite equation like this. और इसका opposite क्या हो जाता है हमारा differentiation. Is that clear? So you can see that this relationship kind of holds. Okay. Is this clear to everyone? Hello?
Yes, sir.
Okay. Now we will be seeing classification of the signal. Okay. We have already seen classification of system. Now we will be doing classification of signal. Okay. So the very first classification that I will be taking is even and odd. Even and odd classification. So signal is basically function, right? So जितने भी function के classification होते हैं वो सारे के सारे signal के भी classification होते हैं. So even signal किसको बोलेंगे? कोई बता सकता है मुझे? When f of t is equal to what, then we will call this
F of minus t.
f of minus t.
F of minus.
E1.
Then this will be, and here there should be this underlying that for all t, t के सारे वैल्यू के लिए, ठीक है, for all t, then we will call this signal as even, right? And if ft is equal to f of minus t, then for all time t, then this signal will be called what? Odd.
Odd.
Is this clear to everyone?
Yes.
Okay. So there is one immediate concept from, I mean, we will look at that anyway, but most of the time what will happen, that signal is going to be neither even nor odd. Okay. क्या होता है आपका signal maximum? Most of the signals are neither even nor odd, right? Can we all agree on this?
Yes, sir.
कि जितने भी जैसे e to the power t है आपका, is that odd? No. Is that even? No. So most of the signal that we will encounter are going to be neither even nor odd, but you will see later that it's very much desirable to have these kind of symmetry. So this is, we are classifying based on symmetry. Okay, so we want some sort of symmetry there in the signal. Okay, और हम क्या चाहते हैं कि कुछ न कुछ symmetry रहे ही रहे वहां पे. So we want signals to be even and odd. So if we have a signal ft which is neither even nor odd, which is neither even nor odd, then we would like to express this ft as sum of two signals, one of which is even and another of which is going to be odd. हम क्या चाहते हैं कि when we have a signal which is neither even nor odd, that should be expressed as the sum of two signals. One should be even and another should be odd. बात समझ में आ रही है आप लोगों को?
Yes, sir.
It is
Yes, sir.
desirable when you will be doing Fourier series and all that. So you will see that if the signal is even, then you will be the calculation of Fourier series will become much easier. Okay, and in many other situations as well, you will see that if the signal is either even or odd, then it's much easier to do. So even if the signal is neither even nor odd, we would like to express that as the sum of even and odd, and then we will do further analysis. That will make our task much easier later on. Okay. So अब मुझे बता सकते हैं what will be even part in terms of ft? So to do this, let me put t is equal to minus t. Okay, so this is, let's say, equation 1. So we can put t is equal to minus t. So when you put t is equal to minus t, you will have f e of minus t, isn't it? And then after that, you will have f of odd of minus t. So we know that even part, even मतलब सिग्नल क्या होगा ये माइनस टी पे एफ ऑफ टी ही हो जाएगा और ऑड सिग्नल क्या हो जाएगा माइनस ऑफ एफ ऑफ टी हो जाएगा ना ये इज दिस क्लियर
Yes, sir.
सो व्हाट विल बी इवन पार्ट एफ ई ऑफ टी विल बी इक्वल टू इन टर्म्स ऑफ एफ टी इट विल बी एफ ऑफ टी प्लस एफ ऑफ माइनस टी एंड दैट डिवाइडेड बाई 2 ओके एंड ऑड पार्ट क्या होगा आपका एफ ऑफ टी minus f of minus t and that is divided by 2. So this part is called even part of the signal and this part is called odd part of the signal. Is that clear? इसको क्या बोलेंगे हम लोग even signal even part of ft and what this is going to be odd part of ft. You see that there is no trick. बहुत ज़्यादा trick नहीं होता है. Thing is that if you are good in basic analysis, then you will be able to solve the question very quickly. Okay? तो आपको कोई भी signal मिले तो आपको उसका even और odd part निकालने आना चाहिए. Okay? So let's say that I'm going to give you a signal which is neither even nor odd. So t plus t square. Okay? What will be its even part and what will be its odd part? Can you tell me?
Sir, t square even and t is odd.
टी स्क्वायर इवन एंड आपको प्रॉपर निकालना पड़ेगा वैसे यहाँ पे डायरेक्टली दिख ही रहा है सर टी विल बी ऑड एंड टी स्क्वायर इज गोइंग टू बी इवन बट यू विल राइट दिस क्या लिखते हैं हम एफ ई टी इवन प्लस ऑड राइट क्या लिखते हैं एफ टी प्लस एफ ऑफ माइनस टी डिवाइडेड बाई 2 सो टी प्लस टी स्क्वायर प्लस टी स्क्वायर एंड माइनस टी पुट कीजिएगा तो माइनस टी आ जाएगा यहाँ पे दिस इज डिवाइडेड बाई 2 विच इज इक्वल टू टी स्क्वायर ओनली and this part will be what t plus t square and then you will have minus of so t square minus t and that is divided by 2 which is equal to t right so it's much easier to see here but then there will be signal which will be kind of difficult to see so let me just give you one other example which you should plot okay so आपको ये मैथमेटिकली करने के साथ साथ आपको ग्राफिकली करने आना चाहिए So let's say that we have a signal e to the power t u of t, which is neither even nor odd. So this is our f of t signal, and this is like this. Okay, so you can write this that it is equal to e to the power t for t greater than equal to 0, and this is equal to 0 for t less than 0. So what this signal is going to look like? Let me draw that as well. So this signal e to the power t has, so it's going to be increasing function after t is equal to 0. And before t is equal to 0, it's kind of decreasing. Isn't it? So it's equal to 0, sorry. It's 0 here for t less than 0 and t greater than 0 के लिए e to the power t है which is going to be increasing, isn't it? So what this function is going to be? So this is f of t. So we have to find out f of minus t as well. How your f of minus t is going to be? Let me just do that as well. आपका f of minus t क्या होता है? You will reflect along y axis. तो y axis से along करोगे तो इधर क्या हो जाएगा 0 और इधर क्या हो जाएगा? It will be like this, isn't it? So this is e to the power t and when you put this यहाँ पे क्या मिलेगा आपको? e to the power minus t, and this will be 0. Is that clear? And now you will be, to get the even part, you will be adding them, isn't it? So f even part क्या होगा fe of t? It will be like this, that you will be adding them and dividing this by 2. So right side में आपको क्या मिलेगा? Increasing function, sorry, इंक्रीजिंग फंक्शन, और लेफ्ट साइड में क्या मिलेगा आपको? यहाँ पे डिक्रीजिंग, आई मीन इट्स अगेन लाइक दैट ओनली. So this is e to the power t and this is e to the power minus t, but this is half of e to the power minus t and this is half of e to the power t. Okay, so that is sorry, we have to add that, so that is going to be odd part, right? ये odd part हो जाएगा आपका. Even part में क्या होगा? दोनों को add करके हम divide करेंगे. So what that is going to be? इधर आपका इंक्रीजिंग मिलेगा और इधर भी आपका इस तरह से इंक्रीजिंग मिलेगा. So this is e to the power minus t, actually half of that, and this is half of e to the power t. Okay, and this value is going to be half here. This is again half and this is minus half here. Okay, so for even signal, odd signal, you can always see that either it will pass through 0 और इसका जो immediately right side में value है और immediately left side में value है, दोनों का sum जो है वो 0 होगा. Okay, so that is one feature of odd signal. Is this clear how to get even and odd signal? So let me just give you one example that you can practice. Okay, sorry. So I'm going to draw a signal and you have to आपको निकालना है, आपको practice करना है ये इसका even part और odd part. Okay, so this is like this. So this value here is 1. Let's say this value is 2 and this value is again minus of 1. Okay, so इस signal ft का आपको even और odd part निकालना है. That is going to be your homework. Find even and odd part of this signal. Is this clear? हो जाएगा आप लोगों से ये? Can you try this at home?
Yes, sir.
Okay. Now let's move on from here. We have classified in even and odd. Now we will be classifying in periodic and aperiodic signal. Okay. So periodic and non-periodic signal or aperiodic signal. So ये definition भी आप लोग को already मालूम होगा, right? So when a signal will be called periodic, if f of t can be written as f of t plus t naught for all time t. Okay, element of real number, let me write it here. Means ये basically इस line का meaning क्या होता है? That for t between minus infinity to infinity. Okay, ये line का मतलब basically यही होता है. ठीक है, is that clear? Then signal will be, then ft will be called periodic. ft will be periodic. Okay, and smallest, again look at the word, smallest positive value of t naught for which above equation holds, holds is called, क्या बोलते हैं उसको हम लोग? What do we call this T naught? If this is the
Fundamental
smallest
period.
fundamental frequency, fundamental time period, right? It is called fundamental period. Is this clear to everyone? Now there will be
Yes, sir.
signal in which ft plus f of t plus t naught is going to hold, but you can't find smallest positive value there. Okay, they are periodic, but their period is undefined. Is that clear? Can you give me an example of the signal which is periodic but its fundamental period is undefined? ऐसा कोई एग्जांपल दे सकते हैं? Yes.
It should be DC signal.
DC signal is one such signal, isn't it? Let me just draw this. So what is DC signal? Let's say xt is equal to 1 for all time t, isn't it? For all time t element of real number. That is DC signal. So let me just plot this as well. So आपका DC signal कैसा रहेगा? It will be constant, isn't it? For all time t, right? Can you give me T naught here? What will be T naught? Can you define it? What will be T naught? Smallest positive value.
Infinity.
Infinity smallest है.
Zero.
Zero positive है. Zero is non-negative number, okay? Zero is not positive, neither it is negative. It's non-positive and non-negative. बात समझ में आ रहा है? So zero can't be, you can't write zero and you can't write infinity, isn't it? Can you see that it's impossible to find T naught here, right? Though it's periodic, it's repeating itself. Periodic means the signal has to repeat itself, isn't it? It's repeating at every instant, isn't it? But that smallest value is undefined. Can you see that? समझ रहा है आप लोगों को?
Yes, sir.
So T naught can't be defined here, but it is periodic. That's true. Okay. One more thing that is by definition here, that if a signal is periodic, it should exist from minus infinity to infinity. यहाँ पे क्या लिखा है? For all t element of real number between t equal to minus infinity to infinity. So by definition, a periodic signal must exist from minus infinity to infinity. Is this clear? So let me just write this. Okay, it's important concept here, that a periodic signal must exist from minus infinity to plus infinity. Is this clear? Is this clear to everyone?
Yes, sir.
Okay.
Sir,
हाँ बोलिए. If you have any doubt, you can ask.
यस, कोई पूछ रहा था क्वेश्चन, आस्क नो.
Okay. Now we have fundamental period T naught, and T naught is related with fundamental frequency F naught. Okay, and F naught is defined as 1 by T naught. Okay, F naught को क्या बोलते हैं ऐसी स्थिति में? 1 by T naught, and that is, what is F naught? F naught is fundamental frequency. Okay, is this clear to everyone?
Yes, sir.
Okay, and one of the example of periodic signal is your basic sinusoidal signal, isn't it? So xt is equal to a basic sinusoidal signal is written like this: a cos 2 pi f naught t plus phi. Okay, here f naught is what? Fundamental frequency. This phi is what? Phase angle, isn't it? And what is a? Can somebody tell me? क्या बोलते हैं
Amplitude.
इसको? Amplitude.
This
क्या बोल रहे हैं? Is that clear to everyone?
yes,
Yes, sir.
Okay, now there is one more question here, that let's say xt is linear combination of two signals. Okay, x1t plus x2t. Okay, we have x1t, and x1t is given as periodic with t1, and x2t is periodic with fundamental frequency with fundamental period t2. Okay, just tell me whether xt is periodic or not. Can you tell me if xt is periodic,
Periodic.
or it's always periodic, or is there condition there?
not all.
It's not always periodic, right? So under what
X1
condition it's going to be periodic?
sir, x1 of t should not be equal to x2 of t.
नहीं, वो नहीं है.
So T1 by T2 should be real.
T1 and T2 should be real. Real तो हमेशा रहेगा. T1 is real
Rational.
and T2 is real, right? T is
Should be
real
rational.
only. Should be rational, right? If it is not, देखो, what does it mean? That let me just explore this, and that will be, it should be much clear to you. Let's say that, let's assume that xt is periodic with let's say t naught. Okay, क्लियर है? इसका मतलब क्या हुआ? xt plus t naught must be equal to xt. यही हुआ ना इसका मीनिंग?
Yes, sir.
Right, and let me just write this. What is xt? Xt is x1 t plus t naught plus x2, and I mean it can be a combination here. So let me write this two constant here as well, a1, and here let me write a2 times a1 and a2 are just scalar value, some मतलब number है. इसका मतलब क्या है कि लीनियर कॉम्बिनेशन है xt x1 और x2 का. Okay, so let me just write this: a1 x1t plus a2 x2 of t plus t naught must be equal to x1t plus x2t, isn't it? Right? होगा ना ये? xt की वैल्यू
Yes,
मैंने
sir.
बस
Yes,
लिख
sir.
दिया इसके टर्म में. अब x1t is periodic with t1 and x2t is periodic with t2. What does this mean? It means that the t naught that you are getting, it must be integer multiple of t1. So m is just an integer here, and it must be some integer multiple of t2. Can I say that? x1 भी t नॉट के साथ पेरियोडिक होगा. अगर xt पेरियोडिक है, इसका मतलब क्या है? x1t is also periodic with t नॉट. तो t नॉट के साथ पेरियोडिक कब होगा? जब इंटीजर मल्टीपल होगा t1 का. और x2 t नॉट के साथ कब पेरियोडिक होगा? जब t नॉट इंटीजर मल्टीपल होगा t2 का. इज दिस क्लियर? ये समझ में आ रहा है आप लोगों को?
Yes.
What does this mean? It means that t1 divided by t2 will be equal to what? N divided by m. What is n? Integer. What is m? Integer. So you are getting ratio of integers, isn't it? और रेशियो ऑफ इंटीजर्स को क्या बोलते हैं हम लोग? रैशनल. Right? So T1 and T2 must be rational, and this same concept can be extended to, n number of periodic signal. Are you getting my? We have taken example of 2, but it can be extended to n number of periodic signal. Is that clear? So if xt is, let's say, combination of a1 x1t plus a2 x2t all the way up to, let's say, n. So an x n t, and here x1t is periodic with t1, this is t2, this is all the way up to tn. Is that clear? Then t naught क्या होगा आपका? LCM होगा t1 t2 t3 all the way up to tn का. Okay, we want least, right? हम minimum t naught क्या है? t naught by definition is क्या है? स्मॉलेस्ट पॉजिटिव नंबर. सो बाय डेफिनेशन क्या हो जाएगा? ये एलसीएम हो जाएगा. इज दिस क्लियर? एंड दूसरा क्या है कि ऑल दिस, इनका रेशियो क्या होना चाहिए? इंटीजर होना चाहिए, रेशनल होना चाहिए. इज दैट क्लियर? If you take these ratio, that ratio has to be rational. Any two if you take, that has to be rational. Okay, and then only it's going to be periodic. So let me just give you based on this, and similarly if you are talking in terms of f naught, then it will be HCF of highest common factor of f1 f2. Let me just write this dot 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 f of n. Okay, so this is how you can calculate पेरियोडिसिटी. ओके, सो टी नॉट इस तरह से कैलकुलेट करेंगे और आप एफ नॉट इस तरह से कैलकुलेट करेंगे. इज दैट क्लियर टू एवरीवन? And let me give you an example here that you can tell me whether that is periodic or not. xt is given as cos of 2 pi t प्लस यहाँ पे आपको है sin 3t. Tell me whether this signal is periodic or not.
Sir, not periodic.
It's not periodic, right? Not periodic. Why it is not periodic? If you take the ratio of like angular frequency का भी ratio ले सकते हैं हम लोग. So omega 1 divided by omega 2. What is omega 1 here is 2 pi, right? And what is omega 2 here is 3. So you are getting 2 pi 3 pi. Is this a rational number? 2 by 3 pi rational number है?
No, sir, it is.
Irrational.
No.
And that's why it is not periodic. Is this? I think it should be clear to all of you, right? Let me give you another signal. We have xt, and xt is, let's say, cos 2 pi t plus sine 3 pi t plus again cos 5 pi t. Tell me whether this is periodic or not, and if it is periodic, what is its fundamental frequency or what is its fundamental period? Is it periodic?
Yes, sir. Periodic.
So
Yes.
fundamental period कितना है आप लोगों का?
7.5.
Okay, let's check that. So F1 turns out to be equal to 1 here, right? F2 turns out to be equal to how much F2 is going to be here? Can somebody tell me?
1.5
yani 3 by 2, isn't it? How much F3 is going to be here?
5 by 2.
5 by
5 by 2. Okay, very good. Very good now. So F0 will be LCM HCF of, right? F0 में क्या करते हैं हम HCF निकालते हैं. F1, F2 and F3, right? So that is equal to HCF of 1, 3 by 2 and 5 by 2. तो इस तरह का HCF कैसे निकालते हैं फ्रैक्शन वाले को? ऊपर वाले का HCF निकालते हैं न्यूमरेटर का. HCF इसका मतलब क्या हुआ? HCF of 1, 3, 5 divided by LCM of what is denominator 1 by 1. 1 इसका क्या है 2 और इसका क्या है 2. बताइए क्या होगा LCM HCF 135 का?
15.
HCF 135 का HCF क्या होगा? हाईएस्ट कॉमन फैक्टर.
1.
1.
और LCM क्या होगा 122 का? 2. तो क्या मिला आपको F0? Got F0 as equal to half. And if you divide each frequency by this F0, you will find an integer number. 1 को हाफ से डिवाइड करो कितना मिलेगा 2. 3 by 2 को हाफ से डिवाइड करो कितना मिलेगा 3. 5 by 2 को हाफ से डिवाइड करो कितना मिलेगा 5. Are you getting my point? और अगर आप T1 T2 के टर्म में देखेंगे, let me just do this in terms of T1 as well. So T1 here is going to be 1. What will be T2? 2 by 3, right? What will be T3? 2 by 5. And if we calculate T0, T0 क्या मिलेगा आपका? यहां से T0 क्या मिला है आपको? 2, right? इसमें देखते हैं कितना मिलता है. T0 will be LCM of T1, T2, T3, भूल गया. So LCM of क्या है हमारे पास 1, 2 by 3 and 2 by 5, राइट? यही मिला ना। एंड एलसीएम जब फ्रैक्शन का निकालते हैं तो हम क्या करते हैं, ऊपर वाले का एलसीएम लेते हैं, न्यूमरेटर का, यानी 1 2 एंड 2, और नीचे वाले का एचसीएफ लेते हैं, एचसीएफ ऑफ 1 3 एंड 5. So this will be 2 and this will be what, 1. So क्या मिला आपको, 2. क्लियर है? अब 2 को अगर आप इंडिविजुअल T1 T2 से डिवाइड करेंगे तो आपको नंबर मिलना चाहिए, राइट? यू डिवाइड दिस एंड यू विल गेट व्हाट, 2 को डिवाइड करो 1 से 2 मिला, 2 को डिवाइड करो 2/3 से क्या मिला, 3, 2 को डिवाइड करो 2/5 से क्या मिला आपको, 5. You should get integer numbers, okay? So that is kind of cross check when you are solving these type of problem. I hope that this is clear to all of you. Hello? Clear है सबको ये?
Yes, sir.
Okay, okay, okay. So next जो सेशन होगा उसमें हम लोग discrete sinusoidals का देखेंगे कि whether discrete sinusoidal are periodic or not, and we will extend, हम यहीं से अपना definition, sorry, अपना डिस्कशन आगे बढ़ाएंगे, ठीक है? एंड आई होप दैट यू ट्राई टू सोल्व सम प्रॉब्लम. सिग्नल सिस्टम की कोई भी अच्छी बुक लेके आप लोग ट्राई कर सकते हैं. ओके, सो शुड वी एंड दिस मीटिंग नाउ? हेलो,
Thank you, sir.
okay, thank you very much for joining in, and let's meet on Friday and we will extend our discussion from there. Thank you everyone for joining in.
Thank you, sir.